Okay, so chapter 1 is your energy usage in the United States and the world. So we're going to get into alternative energy systems and applications in this chapter. Okay, so the very first thing you have to know is your energy source. So we're using two major sources of energy. The first one we call it muscular because we use the manual labor in the animals, and the other one is from the plant, so biomass. So we got the energy by burning the wood. Okay, so you get heat, and also you can use that energy for cooking, etc., etc. And this one is pretty new. Okay, in the modern civilization, we try to harvest the energy from the nature. So we've got windmills, and right now, because this textbook is a little bit old, so I will put right here the solar. Okay, so the windmills and the solars are coming in, but this is just trying to review your evolution of energy sources. So if you get this two thing, that is all right. Okay. And if you think about the energy evolution, you definitely need to know about coal. So we use coal mainly for steam engines, and we also use coal a lot, okay, heavily used in power plants to generate power. So make sure you get these two key points. 20th century, we shift to oil, and then we use it in the internal combustion engine and also the oil-powered ships. In the late 20th century, we move into petroleum. Okay, of course we use the natural gas and the nuclear fission because they're very great energy sources and also very efficient. Okay, 21st century, we use more on the natural gas, and we explore for clean and coal technology, meaning that we're trying to get rid of the carbon, okay, carbon zero stuff that we're doing right now. So it means a clean and then coal technology. And also biofuel, right, is a very is a growing field in energy. Of course, nuclear energy, that's very big. Okay, we use heavily on nuclear energy in industries. They're not very healthy. Okay, it's not good for environment, but very efficient. You can be able to get a lot of power out of nuclear energy. And production is also efficient. Okay, so therefore we continue to use it. The next one is hydrogen. And you have heard a lot about the fuel cells for our vehicles, which is alternative for gas and diesel and electric cars. Okay, so you can see hydrogen fuel cell car as well. So these are everything that we're doing in the 21st century for energy sources. Right, so you've got coal and then oil, natural gas. We try to make it clean and environmentally friendly. Then we use the biofuels. We still use the nuclear energy. And we're getting into hydrogen fuel cells, right? Make sure you get all of this. Just a little cartoon to take a break, because energy is pretty expensive. Of course, we have many different competitors in the energy market. Okay. So when we take a look at the history, all right, of your energy usage in the U.S., until 1800s, we used mostly wood. So after 1850, we got into coal. And for energy consumption in the United States, so in 1870, we used we use wood 70%. In 1900, we used coal 70%. And in 1960, we used oil and gas 70%. So why these changes? Well, that's because of the changes in the energy technologies. Okay. Also, of course, changes in the provision of your energy services. So what are your energy services? They're your heating, your cooling, lighting, and also your mechanical power to run all kinds of machines and devices. Okay. This is reiterating again. So get into 1900, we used coal more than wood, and then we got into petroleum. Yeah. So petroleum became a very important energy source. Okay, so when we get to 1950, then we use petroleum more than coal. Also, we used natural gas. Yeah. When we take a look at the history, not the energy usage, but the oil business, you need to know, right? Because oil business started in the United States, in Pennsylvania. So you definitely need to know Edwin Drake, right? He's very important because he got the oil out of the ground by drilling, right? The oil well. So this drill technology started off from this guy, Edwin. He was just a railroad conductor, but in industrial field, you definitely need to know, right? Oil business, your petroleum, and your natural gas, because they're very important, very big businesses here. Okay, so now we get into the EIA energy flow diagram. You have to know how to read this diagram. Okay, I'll show you in the next slide. So EIA is nothing but the energy information, all right, administration. This is completely your government, and the flow diagram. This flow diagram is just a standard diagram, right, expressing your energy flow. Okay, so let's take a look at the characteristics of this diagram. So in this diagram, you definitely need to know quarts, right? So that's your unit, and we call it in a BTU, right? They go by 10, this is power, so 10 to the power 15 BTU. So as you know, if we use the exponent, the figure, meaning like the number, is very, very big, okay? Here we have a positive sign right here is hidden. If you have negative sign, it means very, very small. So here is very, very big, and quarts is nothing but your energy usage unit that we use especially for the EIA diagram. Okay, so every time you see the EIA diagram, you should be able to read it and you understand this is a unit that we use. So when you take a look at this diagram, we have left and we have right. So on the left, you're going to see your energy sources. On the right, so jump here, come right over here. So you're going to see on the right side, you will have your energy usage. Okay, left sources, right usages. So when you take a look at the sources, you're going to see they are summed and then expressed, right, in terms of your domestic production and your imports. Imports mean we don't have enough, so therefore we have to buy from other people's country into our country. Right? Production meaning like we have a lot, we are producing, right? And we call that the domestic production. So these are the characteristic, foundation characteristic that you need to know about this flow diagram. Okay, you don't have to go into so much detail, but know what's on the right, what's on the left. Sorry, what's on the left, what's on the right, and then you know what is your energy source and what's your unit. So if you get this much, that's going to be great. Alright, then I'm going to show you the next slide, and you will take a look at how the diagram look like. Okay, so this is your 2007 example of the United States energy flow diagram. On the left, your sources on the right, okay, your usages. And again, they are in a BTU unit, energy unit. You can see your domestic production here, your number there. And then we have our imports, okay? So meaning this is a good shape for business because we are producing more than importing, okay? That is also related to your the national income and also spending. So anyway, you don't have to go into that direction. But if you know how this diagram looks like, and then where the things are, and then the numbers and the unit, and you're okay. Another example, right? This example is from 2011. You can also go to their website and download, right, or research on these diagrams if you're curious about it. The same thing, your sources, okay, your usage, and then your production, domestic, and that's, see, like that's, it's really high, and here import, so that's a good business for that year, yeah. And then we have also exports here, right? And we have different energy, all right? You have natural gas here, your coal is right here, your fossil fuels, right? The petroleum, right? It's very big here. Look at that, yeah? And then your natural gas. And we have nuclear power, and then renewable, right? Getting into it. So here are different types of energy, right? And flow meaning like your sources and your usage. Sources, right? We produce some of them, we import, right? And these are the different types, right, that we're using here. Yeah, you see your residential, your commercial, and then your industrial, and then your transportation. Yeah, so usually industrial is really high, transportation very high, right? Your residential, of course, and commercial is going to be this commercial meaning like they're not industrial, they're just like a medium, right, size. Some large corporation, medium-sized businesses, and of course small businesses. They don't use a lot of power anyway. So anyway, you got the idea. It's flowing this way, right? I would put a arrow so student get, but that's okay. Here is without the arrow. So anyway, the direction of the energy flow from here to from the left all the way to the right side. Yep. Sources from coal, natural gas, oil, okay, NGPL, your nuclear, electric power, your renewable energy, okay. These are imports. See how curious, right? How curious this one is. Look at that. Petroleum we're importing, yeah. And the rest of them we can get from here, right? So if politics want to play something, they hit it on here really hard. So import have incredible amount of issues, and you have to do any kind of trade again, yeah, in order for us to be able to get this, right? So right now, what are our strategies? So to solve the import issues, okay, other people country trying to make issue out of this petroleum import because you depend on it, yeah. So you gotta change into electric instead of petroleum, you know, in order to satisfy the industry, transportation, and all other usage. Okay, so you kind of get the idea by just looking at the diagram and also the numbers. Yeah. Even though it is just a weird diagram here, it's definitely telling you business, yeah, energy business of the United States in connection right here with the other countries. Alright, so this is, I'm not going to reiterate the same thing. Yeah, you got the idea. And this is an example for 2014. So what you have to do is just go there in your textbook and then read. Yeah. Now here, we're going to break down the usage and the production, okay, of your energy. So here, the usage, where are we using? You can take a look at this little diagram right there, and you can see, oh, 18%, yeah. Using where? So look at the color, you know, right here. So we're using commercial. 32% your industry. 29% is your transportation. And then residential is the rest of 21%. Okay, they all made up to 100% of US energy usage. So I want you to get right this ratios. Yeah, that's 18%, 18 out of 100. Yeah. So 21 mean like we're taking residential is taking 21 out of 100. Of course, 32 is pretty big on industry because they are industry, and 29 is all other businesses. Yeah. All right, then we get into production. We take a look at this diagram, the same thing, and you can be able to start with this little 7%. You know, look at the color. So that's renewable right there. And then you have 8% your nuclear. And then we have our 22% we produce, right, this energy from coal. 20% of the US energy is produced from natural gas, and then 39% is petroleum, right? So this is in the 21st century. So you can be able to see the energy production, right, mainly comes from petroleum. Then natural gas, right? So if I ask you 21st century energy source, you gotta get this two thing right there. Yeah. If you're gonna give me like nuclear, coal, or renewable, that would be wrong. Yeah. So a student usually think like nuclear is pretty big. It is true, but it's not big in US, right? It is big in the world because especially like in Russia, because they can't get these things, you know. So therefore they go. So it depends on the country and where they are, and what kind of resources their countries right have, and depends on all the factors. The energy production right is different. But for United States, this is what we have, right? So make sure you get this two thing very, very clearly. So today we're getting into renewable energy. So you have to know the breakdowns of all of that. So from previous diagram, we know about 7%, yeah, is on renewable energy. So let's break that down. What kind of renewable energy sources? So we have solar, 1%, wind, 5%. We have geothermal, right? The heat from the ground is your 5%. The heat meaning like energy from the ground, okay? And then we have waste, 6%, meaning like we extract the energy out of our waste. And we have a biofuels, and that's a 15%. We have wood. So that this is just a regular, right? A long time ago we used wood, and we continue to do it so. But then now we group the wood into the renewable energy because wood, as you know, right? They come from trees, and trees they regrow. Yeah, we systematically plant the trees. The wooded forests are in systematic plantation, right? The U.S. Forest Department, they take care of that, yeah. And then your hydro and electric is 36%. So make sure you know what are the renewable energy sources. 1, 2, 3, 4, 5, 6, and 7. All right. So students usually miss this one. All right. They usually think like this is a main energy source. Yes, it was true once, right? So before 1800 wood, right, was the main energy source, but now it is under renewable energy. So if you think about your muscular and also your biomass, right, two different sources of energy, at that time wood is going to go into your tree, right, burning category right there. So anyway, get solar, wind, geothermal, waste, biofuel, wood, hydroelectric, and I am pointing this out again. Don't forget wood, right? That's like pretty big in renewable energy, 32%. The highest is 36% of this 7%. Okay, this too. And if I ask you, give me the renewable energy, you come with solar and wind instead of this two. So I don't know why. Yeah. So make sure you get this two. Right, the highest percentage for renewable energy again are hydroelectric and wood, right? Solar and wind. Look at this percentage, pretty low, right? That's why we are promoting, right, these two renewable energy sources. A lot of the people are skeptical about the wind generators because they mess up with the birds, right? Also very complicated structure that you need to design and very localized, right? That's the reason why people don't want to go into wind generator and also solar generator, the same thing. They worry that you're not going to get the power constantly, but that's not true. Actually, solar you can get, even though it goes cloudy or it goes rainy or snowing, you still get power because you don't need a sunny day to get solar power, right? So that's one misconception public is understanding. But it takes, like every transition in the energy sources or production or energy generation, we it always takes time, right, for the people to be able to clear off all these misconceptions. Yeah, so a lot of government incentives are going on in wind and also solar power. So if you have your house, you can be able to get some money. Yeah, if you change from energy electric grid, right, into the solar power. If you want to do it, you can do that change over to solar. Yeah, and don't be skeptical about it because you can harvest solar energy even in the rainy day or snowing day or cloudy days. Okay. Okay, so from our energy flow diagram, we're going to extract only the petroleum flow. So petroleum, if you recall from the energy diagram, you know that petroleum is definitely on the import, right, site for the sources, and then going into industry and also transportation, right? So for United States, we're going to concentrate petroleum flow, and you're going to see this diagram. So where do they come from? So here, look at this. So petroleum sources are from crude oil, all right? So you can see imports, and then you can see production. So two different sources, all right, for crude oil. So that's petroleum coming in, and then flowing into the usage. So we are using in industry, and we're using, oh my gosh, look at that. What is this? Transportation, yeah? So this is a reason why we have to do the drastic change over to the electric cars because of this, because it's very expensive, right? Very expensive for us to get petroleum from other people's country. You even have to go war with them, right? Different issues going on politically. But then we need it to use in transportation, right? If you don't have it, everything we call like the supply chain issue is going on right there. Yeah, it's because one of the factors is because of this. Yeah, since you don't want any kind of influence or threats by other people country, and we also want to keep this petroleum flow going, all right? We're doing the changeover, right, from the gas car into electric car, right? So that way we can solve two major things. So by changing gas into electric cars, we have two major benefits. The very first one is getting rid of the carbon. We call that carbon, all right, sub-zero carbon emission. We want to reduce it, reduction in carbon emission, all that issue. We can solve that. Yeah. The second one is this issue. Yeah. So you can cut out all kinds of international issues, right, with other people country, and we can also save the transportation, keep going. Yeah. The changes, of course, gradual. It's going to take a few decades to do that. Yeah. Maybe take about 5 decades to do the complete changeover. And for United States, we gotta go all completed by 2050, right? So you will be old at that time, but expect that, right? As we grow older, so we'll be seeing all electric cars by that time. So no more. Again, try to get that knowledge. One is reducing the carbon emission, right? Because if you use a gas car, what's happening is your car engine has something called catalytic converter. So every time you burn the fuel inside of the car engine, you get carbon monoxide. Carbon monoxide is a very poisonous gas. Okay, you don't want that kind of gas floating in the atmosphere. And carbon monoxide can come out if your catalytic converter fails, all right? And the catalytic converter in your car can fail, right? Because a lot of the drivers or the car owners, they don't do the regular maintenance, yeah? They just use it until the car breaks down somewhere, yeah? So you have no idea whether your car is, all right, your car has an efficient catalytic converter, or your car, right, catalytic converter is failing, right, because of aging of that car. Everybody grows old, also car, right, they grow old. So that's the reason why you have to get rid of it at certain mileage, otherwise you can't use it. Okay, it will be running, but you will be directly introducing poisonous, especially the carbon monoxide, into the atmosphere. So now you think of the numbers. So your numbers are, we have too many cars in the whole world, yeah, billions of cars. So that's the number you have to think about. You have your car, your mother has a car, your father has a car, your brother has a car, and then like your sister has a car and your aunt, your uncle have their own car. So if you think about the number, that's the number we're dealing with, all right, in the whole world. So, and all the carbon monoxide coming out, right, from, and not all these cars have the perfect engine or perfect catalytic converter, right? So we have no idea the carbon dioxide, carbon monoxide is converted, all right, perfectly and efficiently into carbon dioxide, yeah? Carbon dioxide is okay in the atmosphere and we need it. It is a part of our atmosphere, and trees, they breathe carbon dioxide, okay? So it's good for the plantation, and we're okay breathing carbon dioxide because it's definitely not poisonous to us. But carbon monoxide, okay, it's a CO, so I can write that down for you. So that's a CO. I gotta teach you this in energy class all the time. And the other one is CO2, yeah, right there. In some of the class, we don't, right, show the catalytic converter, things like that. We just say like, oh, car emits the carbon monoxide, right, things like that, and didn't tell you, right, I'm just gonna write it CAT, yeah, my writing is not very good here, whatever. So anyway, your car engine has a converter, something called catalytic converter, is changing this poisonous carbon dioxide into carbon monoxide, right? Monod meaning like there's only one single oxygen, all right, in that compound. This is gas, by the way, you can see. And then into a carbon dioxide, meaning you have two oxygen in the compound, right? So that's what your car gas, all right, car engine is doing when it burns the fuel. So if the catalytic converter, if that part of your car system fails, right, this process is going to mess up, meaning like carbon monoxide is not going to change 100% into carbon dioxide. It will leak, okay? And where is it going? It's going into your atmosphere, and you are breathing it. So we're all breathing, actually, both of them, okay? Because not all cars are perfect. Some of the cars are broken. Some of the cars are very, very old and still running on the road. So this is the reason why we have to change electric cars, okay? So don't feel very skeptical about it. It is necessary, right? Because carbon monoxide kills, right, and also introduce all kinds of cancer in the world, okay? So therefore we don't want it. So anyway, you got the petroleum flow in the US coming from crude oil, right? Production, that's domestic, we make it, and this is imports, is always higher than production, and we use, especially for transportation and industry, and then the rest of them, yeah, your residential and commercial. Okay. All right, then we're gonna get into numbers, yeah, percentage. The same thing, the diagram, I just explained that to you, and we will gonna go over that again. So from that figure, we know, yeah, we import more than we produce. Yes, import is about 10, and then your production is about 5, if you remember. Yeah, then we use heavily on transportation right here. Yeah, about 69%. If you don't remember, that's okay, but just remember 69. Yeah. Industrial usage about 25%. Yeah, followed by actually transportation is the biggest, followed by industry, okay, and then followed by residential and commercial. Yeah, so these two together, combine all of that, is your 9%. Yeah, so you can see how very important this transportation issue that we gotta solve. Yeah, research is nothing but we gotta solve issue, and you have to think. So professors are mostly researchers, okay? Even though you're teaching or even though you're researching, we still have to come up with the ideas. So the ideas are mostly solving the problems of the world, and we call it problems of the world because an individual cannot be able to solve that problem. Okay, you have to, not even a single country can be able to solve world problem. You have to solve it internationally together. Okay, all because we're sharing the same planet. So whatever we do affect everybody in the world. Okay, and the effects are very difficult to correct. Okay, because it's going with a global scale. What one country can do cannot be able to solve the problem of the world, right? So you gotta understand also these things. You come to the university to study, not to get a degree, but to broaden your understanding and to change the way you think. Okay, you have to think 360 degrees around, and not to just think only for yourself or your family or your country, right? You have to, or your state or country, you have to think for everybody. Okay, that way of thinking is very important, and you can be able to get by coming to the university and learning, right, from all these professors who are actively studying these things every day. Okay, all right. Okay, so this is your natural gas flow diagram. And the first thing you have to know about the natural gas usage, we use, right, trillions of cubic feet per unit. And when you take a look at the imports, right, we use about like 18%, right, for the total usage. So here in industry, okay, and also in electric power we use. So these two combined is about 64% of the total usage. Then of course we use in residential and also commercial. And here you can see a very, very thin line for transportation. That means like we do not use natural gas as much as we use petroleum in transportation. Yeah. Okay, that's all you have to know about your natural gas. Okay, so then we will get into coal. So coal consumption and usage, we use millions, millions of short tons. So that's just a unit for coal usage, right? So we have already introduced you many different kinds of units. So make sure you get them for your quizzes and also final. So for coal, it's all about the domestic production. We do not import coal from other people's country because we don't need it. We've got it right here. And this is the one and only energy source, right, that we don't import at all. So where we using about 93%, we're using coal, right, in electricity, and about 8%, okay, in industrial applications. Yeah. So if I ask you, oh blank, right, we use blank energy source for industrial application, you've got to understand. Yeah? And you shouldn't put coal, all right, for it, because we use only 8% of coal energy in industry. Yeah. So for coal, you've got to know about 93% we're using for what? Generation of electricity. Yeah. And this is again knowledge. We want to cut this off, and we call it getting into the renewable energy sources in order to cut down this coal usage for electric production. So your electricity you're using at your home, okay, you think like you're not doing any kind of emission, but you are doing the greatest emission of all, right? Because it came from what source? It came from coal. Yeah. So that's a direct carbon emission right there. Yes, so everybody using electricity. Okay. And you're gonna have an issue when we say like going electrification. So that's another word that you have to know for today. Energy problem solving, electrification, meaning like we try to change the processes in the manufacturing industry, right? Going from coal into electric, right? Total electric, meaning like we're trying to reduce this, right? And turning other energy sources, getting rid of this energy source, right? Because it's making incredible amount of emission. So wording is a little bit deviating, yeah. And that is what the last, right? This little bullet point is talking about. Why coal is a problem? Because, all right, it gives you like significant environmental problems, right? I should say like tremendous environmental problems. Why is it tremendous? Or just the air, but that air in the world, all right, it moves, and we call that the air currents, yeah? The wind currents, right? And we have the water currents. So you don't want to mess up with the ocean and the atmosphere because they move, right? They have mobility. So if somebody is doing something in this country, it's going to go to the other country. So the other country don't want to get that effect in this country. Okay, so that's the reason why a lot of laws, incredible amount of environmental laws, punishment, which is your penalty, right? Fines, policies. So the international policy, if you get into Google searches, you're going to see incredible amount of policies protecting, all right, the air current, the water current. So in other words, your wind currents and your ocean currents, because they carry things that you don't want from other people's country into your country. Okay. Some people got to get into temperature, so that's we call that the global warming, but the term is deviating. Okay, that's why it gives you incredible amount of misconception. It all depends on, all right, the changes in the two currents, your water and your air, your wind, all right, and the other one is your ocean, okay, because the movement of that two things heavily depend on the heat, okay, or the temperature of the world, because changes in the temperature can mess up that two currents, yeah. And these are not just currents, because the currents carry impurities, right? Some of the impurities are poisonous, right? And these two currents also generate incredible amount of power. And these powers cannot be harvested or used in the way we want it in the system, right? So they carry incredible amount of power, but that power destroy usually, right? The lives of people, like the tornado just happened, right? Down south, hurricanes in Florida, all kinds of stuff. Yeah, you got hit, and these winds are not generated right here in the United States, right? So the air patterns, the wind patterns, all of them, the cloud patterns, all right, the composition in these clouds in the atmosphere, they come from all over the world, right? The pressure differences create all that flow, the airflow. So we're getting it because it's ended right there in Florida, yeah. So and coming up from where? From Europe, yeah. So anyway, that's the reason why we have to get into the climate issue, right? One of them is the temperature. We should change it like temperature, right? Not global warming. We should change the word into the global temperature changes instead of global warming, because they're going with how you feel about the air, not like the composition of the air. The real word is the changes in the composition of the air and the water. Okay, so that's the real word. Science professors and the researcher give it to the public, right? But the reporters and the people outside change it into something weird, and it doesn't. And everybody fight over that term, They just they're supposed to be reading the articles, the real research articles. So we don't use the word global warming. It is actually the changes in the composition, right, of the air and the water, the global air and the global water. Why? Again, because they, all right, can carry. One is a good thing and one is a bad thing, right? One is energy. So we're getting into renewable energy because we want to use that air pattern, all right, and harvest that energy and use it systematically instead of let it go and hit us hurricane and tornado going whatever and hitting everybody along the path. So these are the challenges. Okay, recent researches that going on right all over the world, trying to think how in the world, to play or to control that composition in the air, and to play and to control, right, to manipulate the composition in the water, right, so that we can drive that energy and use in an effective way, instead of let that natural energy going and destroying the people's life and their properties, right? So make sure you try to understand that. This is the reason why we gotta teach, right, what's going on. So you don't have to fight over because of the word global warming. That's not created by the scientists, right? That's just created by people who actually don't know how to explain. Usually I think reporters mess up everything, but then we don't have any kind of control over them because they write it in the way the audience, right, can be able to understand, and it mess up the whole thing. Because if you write it like compositions of the water and air, and then people don't understand what that is, because temperature is just telling you, these particles, the movement of these particles in these air and water masses, right? So the more you move, the temperature increases. The more particles you got, the temperature increases because they move. Okay. Now you know that we have an incredible amount of stuff in the water and also in the global air, so they move. Since the mass is increasing, every time they move, they are increasing energy, and that energy is destroying everything in the path. All right, they move. Yeah. So alternative energy is, why not we harvest the energy systematically? What kind of system do we have to do in order to harvest that energy? Okay, so if hurricane started, what about we harvest that energy? If tornado started, what about we harvest that energy, okay, and change that mobility in a different direction? So these are current research, right, attempting to solve that tornado and hurricane issue, right? Okay, so this chart is just showing you the energy usage, not in the US, right? This is all the world, so around the globe. The picture is not very good right here, so you can go to your textbook, right, and take a look at it, so you can be able to see clearly. Right now it's a little bit difficult, and here you can see your United States and Canada right here. This is our GNP per capita, and then here is your primary energy, right, per capita. Try to understand where we are. We're right here, Okay, so what do we learn from this chart? The most important thing that you need to know is the trend. So developed countries, they use more. Therefore, right here, we're on the top, yeah, more energy than the underdeveloped countries, right here, down there. Okay, so if you get that trend, you're okay. Okay, right. So this diagram is kind of better than the other diagrams. You can see clearly. So here from 1996 to 2005, this is your BTU unit, and we are comparing the world, the US, the China, and the Russia. Right? This is just the industrialized nations, right? Competitors, of course. The competitors for US are China and Russia. Yeah. Energy usage, we can see the world is right there. We're going to break it down into 3 major countries in the world. And you see you're right here, right? Over China and Russia. Yeah. China and Russia, they're kind of okay, yeah, up to 2001. And then China go up, yeah, from 2001 all the way to, of course, now, yeah. And in fact, we have another chart, right, recent chart from 2005 all the way to something this kind of old right here, and you can be able to see that China is going actually over United States, right? That's the reason why you're afraid of these 2 countries, meaning like since the energy usage is going higher, meaning like you have to share the resources to the country using more. You got it? You got the idea. So therefore, the imports is going to get into here, right? So from 1996 all the way to 2001, US, right, we didn't have competitor at that time, meaning like your imports is going to satisfy energy we use a lot, right? Petroleum and for transportation. But from here, you got to fight for that petroleum, right? You have to fight for that petroleum. And your competitors again, or your rival, right? In other words, is China, meaning like the usage, meaning like China is using energy, right, for production or whatever they're using in their country in the China diagram flow right there. So you can study that, but then you have to share the resources with them. Yeah, since you're sharing the resources, which comes out from the limited amount of production, right? Meaning like your ores, okay, produce this amount of petroleum. Now we're getting less, all right, than we used to get, right? Because it's going to the other direction to China, which is growing or developing, yeah? And that rate, look at that here. See how line is so plateau out, very stable. Russia, very stable. Look at the China, it isn't stable. Look at this. This is called what we call an exponential increase, right? This increase is scary, exponential increase. So this is the reason why the politicians all over the world watch China, because of this growth trend, right here. That is very threatening. So when you think about the energy usage, which is linked from the diagram from the energy source, right? That source is going to go into that usage. And with this type of increment, right, is you have to be very careful to the future, yeah? And again, this chart is old, and we have another chart here that is showing the recent. So go back and Google search it, and you can download the recent chart on it. You can be able to see this trend going up, yeah? All right. So another chart right here, and this chart we're concentrating on efficiency, okay? And the numbers, of course, will go with your percentage. So meaning like you add everything up and that you get 100, right, total. And here, we just put a component that's just showing you, different types of things, from production to things that we're using, okay, for energy. So we have large electric generators. Okay, that's a 98 to 99% efficiency, energy efficiency, meaning like we are very effective in making or designing generators, right? So we design a generator in a way to be very energy efficient. What is energy efficient? These devices use very, very minute energy. Okay, so that's what we call it, energy efficiency. Use very little energy. Yeah. Home gas furnaces, 90 to 96%. Small electric motor, 60 to 75%. And I am not going to read the whole thing for you. You just read it and you got the idea, right? So let's go from the bottom. Global photosynthesis energy efficiency is very, very low because this is like showing you 0.3%, right? What does it mean? Again, 0.3% of energy efficiency, meaning global photosynthesis is using incredible amount of energy. Yeah, you got it. Beef production. Yes, beef production. So that's your food, right? Food consumption using incredible amount of energy. Can you believe that? Milk production. Oh my gosh. Yeah. And then your lightings at your home, not efficient. Yeah, they use energy. So anyway, you got it. Okay. Another diagram. So here we got a two, right? A different diagram. These are called pie charts, right? And here you have supply, and here demand. Supply. We have renewable energy, your coal, your natural gas, your petroleum, and then your nuclear. Yeah, wood is out in the century. Demand, we have electricity, your commercial, electricity, your industrial, electricity, your residential, residential and commercial combined together, you add it up, for here, because that's just an overlap. This is a pure, right? Then transportation, and then your industries. Okay, so of course pay attention to all of the percentages right there. Again, unit in BTU, right? This is just a number, 94.6. Trying to compact the number instead of writing, you can write all kinds of zeros right there, yeah. So quadrillion BTU, meaning it's very, very big energy usage. So what is it that you have to know? You have to know, right? U.S. energy supply is 83% of your fossil fuels. Demand, if you look at it, so supply 83%, right? Fossil fuel. Demand broadly distributed, right? In all these sectors. Yeah. Okay, so another chart. Here, when you pay attention to this chart, you have the historic data, right? So we're around here between 2020 to 2025, late, yeah. So we're 2022-ish, end of in 2023, right? So right there, right now. And of course, all of this on this side is your future prediction, and the prediction coming out from right 2 to 3 decades, right, of your, of course you can see the whole thing, so you can get all of the trends, and then you calculate, and we believe that this chart is going to grow in this direction. So this is all prediction, right? When we get to 2035, probably you might get a ditch or something at the time you update the chart. Yeah, this is already done, and from here to there is predicted. So we still see, what do we see? Here on this chart, we see renewables, all right, energy growing rapidly. There it is. But still, your current policy, we're still using fossil fuel, right? About 78%, okay? So meaning like all the energy in the United States, 78%, all right, comes from fossil fuels. So make sure you know what is a fossil fuel. I'm seeing like coal and natural gas and liquid biofuels. Yeah, fossil fuel is review of your chemistry. Yeah, so that's your hydrocarbon and review of your biology. Yeah, so coming from your plants and animal dead ones. So when plants and animal dead, what do? We put them in the ground. Yeah, so they decay, right? Some people don't put the body directly. Some people put animal's body go directly, under the ground. Human body go with a box under the ground, or sometimes we burn it, everything just go back, right, to the ground or to the air. And so you let it remain in there and decay, go through the natural process. And at one point, we can extract it, and then we can burn it. When you burn it, we get energy, and we call those kind of energy from the fossil and then fuels. You know what fossil is, So if you don't remember, then if you don't remember the entire definition, you can say the energy coming from the dead plants and animals, and that process happened under the ground. We dig it out and we process it and then we turn it, into petroleum, and we use it as energy source. Okay, let's stop right here. Okay, so this is just another chart, and the example comes from 2009 data. Okay, but just showing you the electricity generation. We're producing electricity. We produce electricity from fossil fuels. Okay, now you got the idea. we have usage, and that is our transportation using car, petroleum, which is your fossil fuel. Your electricity, again, even if we call electricity, and you have a misconception by using electricity, we're not burning the wood, so therefore, like a carbon usage or carbon emission into the atmosphere must be reduced. But it's not true, because we're still producing electricity by using what? Fossil fuel. Okay, so oh my gosh, yeah. So 70% fossil fuel coming out, right? For your electricity generation coming out from fossil fuels, 70%. The other one, 20% growing, and then 10% is renewable. So here you can see on the pie chart everything. So this section right here is your renewable, right? So our strategy, current strategy, is to increase this, right, and reduce this. We are fighting to reduce this. Why do we have to do it? Because if we don't do it in the future, we're going to be so screwed. Why? Because fossil fuel, it takes a long time, right, for animals and plants to decay and go through that fossil turning process under the ground. It takes millions of years. So all the fuel that we're getting from fossil came from centuries and centuries and centuries ago, right, stuff, and we are lucky. But the thing is, like, the regeneration of that fossil underground is gonna take a long time. So that's what we'll worry about. So therefore, in order to solve the issue, we have to reduce this and we have to increase that. And we have to do it. Why? Because everything that we do depends on how the environment is changing, right? So what is a change in the environment? What's going on? All right, with our planet, right? The planet is Earth, and we are living on it. We are using everything on it. We're digging all the things out of it, right? And we have to realize this planet is literally active. Active means it is cooling down, right? It was a star before, but it is cooling down. Therefore, the planet itself has its own change in energy. You can just dig whatever, you can bury whatever into it, because there are so many processes inside of it that you cannot be able to see, and you don't want to disturb that. Because every time you disturb, right, mass, which is the composition, right, of any object in the universe, you are disturbing its environment, and we're all in it. Okay. We can't stop it, right? We can't stop it. You have to change with the environment, with it. Okay, you can't stop it. Because the change is going on all the time, every moment of the time. So therefore, you have to do everything that depends on the changes in the environment. So what is the changes in the environment in regards to energy? Is this is running out, all right? And you have to do everything you can to increase the technology to harvest the energy from renewable sources. Okay. what do we have? What is increasing? What's increasing is our air, right? And then our water, their current flow is more aggressive than they were before. Okay, so those are the patterns that we're seeing. So we have to move into a little bit. We can't be able to increase so much, you know, so it's going very gradual, 10%. And you and me, we won't be living up to the time they are successful in it either, you know, whatever that is. So right now, that's what we're doing, yeah. 20%, see how the nuclear is used for electricity generation, okay, because we want to reduce this, yeah. All right, this is still an unhealthy process, but we still have to do it. This is very healthy process, but difficult to design that technology, okay. Extract the renewable right here, so that's altogether 10%, yeah, 6, 9, and 3, 6, and then we're gonna break down the same thing. You see the same thing here, your wind, your wood, and your wood derived fuel, and then your geothermal and all the biomass. So even though we select fossil fuels, right, reducing carbon and oil, we still have, we still have the wood and wood derived fuels, right, under the renewable one. But the only difference is this is regenerating, right? This regeneration rate is very, very slow. The regeneration rate for wood and wood derived fuels is actually faster compared to this, okay? So make sure you get that as well. All right, so we're coming into 2011 example. Okay? So here, when you take a look at this diagram, see a lot of arrows, yeah, going in this direction. They have different colors because we have different categories right here. What are we seeing? We're seeing the sources right there. The same thing, your petroleum, your natural gas, your coal, your renewable energy, and your nuclear. And that is going into usage, right? We call it sector usage, the same thing, your transportation, your industry, your residential and commercial, and then your electric power, yeah? So that's showing your primary, main, right, energy consumption by source, and then your sector. And again, pay attention to your unit, yeah? So we're going with the quadrillion BTU, okay? This is very big. Don't forget, that's a very big number, yeah? Even if you're seeing like 97.3, make sure it's very, very big number. So let's pay attention to the source. So again, about 36, petroleum going into where? So you look at it right there. So another percentage right there. So out of 36, 71 going into here. Yeah. Out of 36, 23 going into here. And then out of 36, 5% is going to go into residential and commercial. Out of 36, 1% is going to go into electric power. Okay. So if I ask you petroleum, where are we using, you have to get transportation. If I ask you natural gas, where are we using, you go in there and then study, ding, 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 and then you sort this, yeah? So 33, yeah, highest. So go all the way down and you see natural gas for industry. So if I ask you, oh, where's the coal going? So you see this and that and then this, and then you follow that path and then you ended up right here, electric power. Okay, and then you see the residential energy, renewable energy. Where am I using? You go 13 and then 25 and then 8 and then 54 going again, electric power. And then you go nuclear. Oh, where am I going? So you have only one single right there arrow going into where? Electric power. Yeah. So make sure you get all of that. Concentrate in the highest percentage. Yes, at least petroleum, transportation, natural gas, industry, your coal, electric power, your renewable energy, okay, electric power, your nuclear, right, electric power, again, yeah. So make sure you get all of that, at least. Okay, another chart. Chapter 1 is all about chart. You gotta know how to read it, the diagrams, you gotta know the information in that diagram, right? Good stuff. Okay, what are we seeing right here? So again, credit going to EIA, that's your energy information administration, federal government stuff. Anyway, this guy did that, right? And then so we're having 2000 all the way to 2010 data, right? See, look at that, how beautiful that is. And then you can see the distinct change right here. See that? And then you can see the pattern right there. Okay, from 2006 to 2010, very robust right there. Yeah. So what's going on with all of that? So you look at the color and go, look at this. Oh, that's Pennsylvania. Yeah. Oh, this is Texas. Then you give, where is a little? I can't even see this one. Yeah. Where we can see it. Okay. And here, right? And then here, right there. And then right here. Yeah. And then right there. And then right there. Okay. So make sure you match all the colors to different states in the United States. Okay. And I would take a map of the United States and then mark around all these states if you want to go into further and then try to understand over the last decade what are we doing. So shale gas production. Okay, so that's what we're seeing right here. Yeah, so we can see the fattest one right there. Look at that, and match it. So that's from Texas. I don't care about the town names, nobody's going to ask you about the town, but you know that's, yeah, gas production, you have to get Texas right there, okay? See how we read the graph that way, and don't worry anything about this little town name. You don't have to get all of these details, but you've got to get at least, all right, a general idea of the U.S. shale gas production, all right, increase. It is a 14.4. Look at how fat the graph is. Yeah, this is 5. Here is 1. Yeah, so it go up from 2006 to 2010 that way. So therefore, increased. It is going up. It's not going down. It is going up. So therefore, increase 14-fold. That's about 14-fold. Yeah. So what does it mean? So meaning like comprises about 22% of the total, right, U.S. production. What it comprises? Your gas production is now at about 22%, yeah, in the United States. So this is how you read your information, okay? You always pay attention to very small, right? Look at this, very, very small, right, graph sections, and then you pay attention to the very big, right, section on this graph, and all others just go generalize it. So we know that, all right, Ohio, right, this one is Ohio, right, Indiana, and Michigan, right, so all that 3 states, we can be able to say, right, you know, the gas production, all right, is lowest, yeah. And unit, pay attention for gas production, trillion cubic, we're going by feet, okay. So in US, we're still following the British unit system. We're not using the Systemic International, which is your SI system, but we created that system used by international countries, and so that's kind of like hypocrite, you know. We develop it, then we can't be able to drive the public to use what we have discovered. So we're still under the British, right, unit system, so go by foot, I think pound stuff, yeah. You want to stick to what you're used to. So I think the United States generally resists change, okay, and literacy, I think. So wherever there is a, try to remember 2 things, big ones, Texas, gas production, very heavy, Michigan, your Indiana, and Ohio, gas production, all right, low. The rest of them are these things, okay? So we have 52 states, so you can go over all of that state minus that. The rest of the states, they don't have these resources, yeah, in their state, okay? So if you want to find job, right, in energy, right, you know where to go to look for that job. Where? It's going to be right there, yeah? So you have to work very smart. You don't look for the state where where there's no sources, okay? All right, so finish with this. Okay, another chart. This is beautiful chart, very colorful. Now you know how to read the chart, right? So here, okay, and then here, change, yeah? How is it changing? Going up, increasing, growing, progressing. Okay, so everything. You can change this side, and then you can see this side, and you can see the change in between the two, right? Where is it happening? So it is happening between 2000 to 2010, and you can see the distance, right, happening right there at 2009. These are just relative data, right? If you get like a general idea, it's okay. Coming from the same source right there, so we give the credit to the different unit, okay, billion, kilowatt hours, so everything we see used for kilowatt is going to electricity, okay. Here history, meaning like past data. Here projection, meaning like predictions, okay. Predictions are based on a trend, right, past trend, and when we calculate, we do our algorithm and we calculate it, and we got this. We don't know how that is going to stay or that is going to change, right, going up or down, we don't know. We're going to know when we get there, yeah. So right now we are here, yeah. So far so good, okay. So you can compare the prediction and then the actual, yeah, actual chart, and you will see a bit changes, right? Sometimes you'll see some changes. So that's how we study the data. So 2025 to 2035 is in the future. Yeah. So this book again is a little bit old, yeah, because we're concentrating in around here this decade, from 2005 to 2015, right? This is 2011 outlook, energy outlook. So here, what are we studying? So you can see the non-hydro, okay? Non-hydro meaning like not dealing with hydrogen, yeah? Renewable sources, renewable energy sources right there. So we have waste, solar, we have geothermal, we have wind, and we have biomass, okay? And biomass we're using here in advanced biofuel, concentration, power sector, and also your industries, yeah? So what is the trend we see? Right, increase. So meaning like grow is increase, the same thing is about threefold, yeah. And 22%, right, projected electricity generation growth. So this is just telling you like what we have predicted, we are meeting, right, the prediction in the actual data, right? So how much are we meeting? We're meeting about 22%, okay, of your electricity generation growth. In which sector? In renewable energy sources, yeah, non-hydro part of it. So what else I need to tell you? Oh, okay, we can go back here. The industry CHP is nothing but CHP is abbreviation, right? We call that for the combined heat and power. So H for heat and then P is for power. It's just a term, right? So industry and then combined heat and then power. So that's well, you know, like your energy source and usage from biomass. And don't forget about, oh yeah, I already mentioned the unit for electricity is kilowatt, right, hours. And the other one we use for the BTU, right? And that's for the fuel, right? Fuel and energy. And BTU is nothing but the British thermal unit. So make sure you review your physics. Alright, so this is the last information that you need to know for this chapter. So let's looking at another chart. Yeah, so what are we looking at? So this is just an updated electric power plant, right? We're seeing that the capital costs. So you can see here with the dollars, okay? So don't forget this units, right? So we're dealing with the capital costs, so therefore we go by dollars. And per, since we're dealing with electric power, per kilowatt, okay? Don't forget electricity unit, kilowatt hour. So here we're seeing pretty big, yeah, very big numbers right there. And you are dealing with two data, right? One is your AEO and the other one is AEO 2011 and this one is 2010, coming from the same data source, which is your Energy Information Administration. And this is, again, you can see the very tiny, all right, description right there. And I gotta point that out because this capital cost is an overnight one, right? You don't need to worry about the details, all right? Just pointing this out, because if you go up here on EIA site, you're gonna see a different capital cost. Okay, so this chart is just information on the overnight capital cost. Okay, so what are we seeing? We see increases, yeah, for nuclear, for coal, and then your wind. So here, all these things are right there. So we have our nuclear, and we have our wind, okay? And then we have our coal, right? Right here, okay? And then the last one is solar, okay? So right here, okay? So this is how we read the chart. And then we have two data on AEO 2010, right? And then 2011. What's going on? You see, look at that. 2011 going up, yeah? Here kind of level, yeah? Here also the same thing. I'm coming back because my power went off. Okay, anyway, so I got it. And here is a little bit different. See, solar 2010 is higher than 2011, meaning like it's going down, yeah. And then this is your photovoltaic, right? That's really going down, okay. Different power plant, electric power plant sources. Okay, so anyway, you kind of get the idea, and this is just not, all right, percentage. It's just showing the change in percentage. So you can see plus 1%, meaning like 2011 natural gas going up 1%. Okay, this one, right, 25% up. 2011 pulverized coal going up 25%. Okay, so if you see this kind of question in my quizzes or final exam, you know how to go. Yeah, changes. Okay, plus 39%. I'm not going to torture you by asking you what is this percentage and what is that percentage, but if you are curious, I will go back and review mathematics, right? And you should be able to calculate and come up with what's the percentage of this and what's the percentage of that, okay? Because your information is a change, right? Showing you, oh, 35% change, yeah? And you have information for your dollar amount right there, yeah? That's between $3,000 and $4,000 per kilowatt, yeah? And then this 4,000 in here. So you kind of get the idea and I'll calculate the percentage, yeah? And the changes, of course, from here all the way to here, yeah? So I can draw this out for you. So here you can change that. Change is right there, yeah? See that? I can make a line right here like this for you to make it better. Now you can see clearly, yeah? And of course subtract this, right, out of that, and which is going to give you the dollar change per kilowatt for that capital cost for, right, IGCC and CCS, all right, source, okay? Okay, I'm going to go ahead and stop for this chapter and make sure you pay attention to all the key points that I went over, okay? All right, that's it.